My name's Paul Kinsky, software engineer at Nitro. I work in the platform team. So a while earlier this year, we were trying to decide in a serialization format. The options were Protobuf, Thrift, and Avro, right? So they each have different strengths and weaknesses. Protobuf, we mostly, right. So let's do this proper. All right. Paul Kinsky, graduated computer science at Worcester Polytech over on the other coast. Moved to SF from Boston, just done with winter, platform engineer at Nitro. All right. So on to Avro. So we were deciding between Avro, Thrift, and Protobuf earlier this year, different pluses and minuses for each. Ended up getting to the decision between Protobuf and Avro. And Avro has great support among data science tools. There's a lot of ecosystem. There's great support for Parquet, Spark SQL, tools in Kafka, Camus. But the problem was at this time, jumping around a bit. And like all these different serialization formats, they're all fast, they're all reasonably efficient, they all pack your data down to binary. They all have simple types, right? They all have enumerations, booleans, strings, ints, longs, floats, etc. They all have complex types with a few different wrinkles. So Avro specifically has maps of strings to type T, arrays of type T, and unions which contain some like bundle of types, right? It's sort of like an any type, but you're scoping it down to types A, B, C, etc. So Haskell has this as just like a built-in bit of syntax. It's really nice to use. Scala sort of has this. You have to use libraries like Shapeless, but they're really great. There's some, you don't really need them most of the time, but when you do, there's really no substitute for having an actual union type. And all these Protobuf, Thrift, Avro, et cetera, they all support schema evolution via optional default fields, right? So that's the good part. So here's the problem, the reason that we were on the edge between Protobuf and Avro. So Protobuf doesn't have this great big data community support, but what it does have is some nice type-safe code generation. So Avro, it's only Java code generation. You don't get something that's immutable. You essentially get like a bag of objects which you can put and get via string keys. And you don't even have type safety for union fields, right? It's just an object like everything, most other things. So what we decided to do about that was write our own code generation tool. It generates Scala case classes. It uses shapeless coproducts to represent union types. So you have you can see there, you have this sort of like an H list. You're essentially creating at a type level a list of types and enforcing that you only have one of those types instead of just using any. That's really handy when you need it. When you don't, you can just ignore the type level voodoo. But when you need it, there's really no substitute. So this is all based on Scala PB. It's a Protobuf code generation tool. This is actually one of the cool things about open source, right? If there's something that works really well, that you like the implementation of, that you like the design of, but it doesn't do quite what you want it to, you can actually use that as a starting point for what you want to write. So that's what I did, right? I took Scala PB, I tore out some of the base infrastructure. It's an open source project put out by TrueAccord, and retooled it to work with Avro and to generate different classes and such. So this is what an Avro schema looks like. It's JSON. You can see, here you have the one that's highlighted, that's a line. So you can see it's a namespace that's just a package. It has a type that's record, that's essentially a class, name, line, and some fields, which is just an array with objects. So there you have simple fields, start and end. They're both points. A more complex one, you can see name. It has a list of allowable types, right? That can be null or string. That's how you'd represent an option in Avro schemas. Then you have some other types here, polyline. In there you have an array of points instead of just two of them. Circle, you have a radius, et cetera. And then at the bottom you have draw requests. This is a bit more interesting. It has just a metadata field, nothing important there. But what is important is geometry, right? Its type is a list of, its type is an array of union where it can be a circle, it can be a line, it can be a points. So you want to be able to draw a bunch of different things, and you want to be able to represent, like in a very type-safe way, that this request can only have a point, a line, a polyline, or a circle. So here's actual Scala code. Here's how we deal with this stuff, right? So we're generating point, line, polyline, circle, etc. Here you can see we're creating a type alias for the coproduct of point, line, polyline, circle. And there's a bit of a shapeless voodoo there that you don't really need to use for most of the code gen. But again, when you need a union type, it's really handy to have. So yeah, so it's basically just Scala, right? You have case classes. They have named parameters. You can see here, actually, it works with reserved keywords. I just added that to show that. So if you have type, you can actually, it'll correctly generate code for that. It won't just blow up. Maps, vectors, et cetera, all that like just nice Scala stuff. So here's what the actual generated code looks like. And what's interesting here is I copied the approach from Scala PB of actually generating code and not using macros, because macros are sort of hard to work with, especially if you want to create companion methods or just companion objects, methods on them, et cetera. So you can see here, it's just a case class. It extends some boilerplate generated message and message. You have some like with name, with start, with end convenience functions just for creating a copy with a different name, start, or end. Those are automatically generated from the different fields on the line type. And what's really interesting, down here you have an arbitrary instance. Who's familiar with Scala check? Show of hands. So the idea is with a Scala check is that it provides some machinery for generating random instances of types and then creating tests that attempt to prove a property over all randomly generated instances of those types, as opposed to testing with a single value. So what you get from your generated code here, including or on top of like the case class, on top of the helper methods, is a gen instance. So what we can do with that is actually just generate random lines. And I'm going to drop out of PowerPoint for a second to show you that. Am I in a console or yes? Right. So let's just. So that's the arbitrary instance online. We can just sample it to grab some arbitrary lines. And you can see some of these have names, some of these don't have names because that's an optional field. They have points. Points are also generated from the schema. Those have some of those have names, some don't. And then you just have like random nonsense strings and like huge numbers as their like x and y coordinates. Yeah, so if you use these for your tests, you'll hit edge cases, right? You'll get like 0, you'll get negative numbers, you'll get 1. And then you'll get just like random large numbers, random strings. Maybe you'll get like some characters you didn't expect. It's just a really nice way of structuring your tests. It helps show where you have just basically weaknesses in your code base. So we can do this for a more complicated type, right? So let's do that for draw request. That has a union type that has some arrays. So we're generating here, again, a random draw request. It has a randomly generated metadata field, randomly generated array of union types. It all just works, right? You can use this in your test code, and that just saves a lot of time having that automatically generated. Right. So a few more of, and these are just to show that like there is just a ton of stuff that you have to do to generate code, right? So I'm showing this to highlight one of the coolest things I took from a Scala PB, or used from Scala PB, which is this functional printer. So that lets you just, in a very type-safe way, without using mutability, with allowing you just to use like single expressions for all of your functions, to generate code, or to generate strings rather. Sorry. Right, so let's see how that actually works in practice. So here you can see this is the master class for print, or you can't see because it's still quite small. Right, so this is the master class for printing records. So you just start with a printer, you add your final case class, indent, then you call a sub-function that takes the printer and adds some sequence of fields, you outdent, add your list of what you're extending, et cetera. And you go down, you add some utility methods. And this is all just one expression, right? There's no string buffer here. We're not appending to anything. We're not like going and mutating anything. It's really just very clean and functional. And So again, I want to like call out like True Accord and the people who put together Scala PB. That's where I grabbed the pattern from. Right, so that's what the actual generator code looks like. Let's take a look at what the code that we would use to add this to our project looks like. It's quite simple. First, you just go to the plugins, right, in project. You add, well, this is currently not published, but you add avro-codegen compiler. That's the class that as part of compilation creates these like classes in your source manage folder of your inside target. Let's check it out right here. Right, so this is for some kind of enormous schema that we use to represent PDFs. Then in build.sbt, you just add the runtime component, and this is the companion objects, it's the traits, it's a little other machinery, like, for example, Kafka encoders and decoders. So what's cool about this is since you have the companion object for every generated class, the companion has two mutable from mutable methods for going from this immutable representation to your Avro class that all the existing Avro infrastructure knows how to work with, knows how to write to disk, knows how to serialize and deserialize. So you can just implicitly pull in the companion object just given a type and use that to do your serialization and deserialization. It makes it really easy to create, for example, Kafka consumers and producers that work with like typed Kafka topics. So that'll be a part of this when it's open sourced as well. All right, back to PowerPoint. Back to so yeah, you don't actually have to deal with this yourself, right? There's a lot of boilerplate that you need to go back and forth here. It's just really complicated. It's a lot of writing you'd have to do. Your fingers would get tired. You'd get carpal tunnel, et cetera. So it's much easier just to generate this. So this is used internally at Nitro. We've been using it for a few months. It's been like used across several projects. We'll be open sourcing it in the next several weeks. And yeah, so any questions?
Okay, so we'll use the mic for the question, but please repeat the question because the camera is not picking up this mic, it's picking up your mic.
Right.
So two questions. First, the generated case classes, do they play well with serialization like Quiro or Java serialization? Second question, you mentioned Thrift. So what made you drop Thrift from the evaluation?
All right. First question, how well do these generated case classes play with existing serialization and deserialization frameworks? So the trick here is that they kind of don't, or that's actually incredibly badly phrased. Let me continue to explain. All right, wow, okay, so there's a type in Avro that you have called, let's see, where is that? Generic record. That's how Avro, all the machinery around Avro, all the stuff where it integrates with Parquet, that's how it serializes and deserializes Avro schemas or instances of Avro schemas. So what you do is you transform your case class into a generic record, and then you serialize that generic record.
Yeah, but you do that when you read Avro files from, say, HDFS or before you write to it.
Yes.
Say you have a Spark pipeline where during the shuffle you want to just serialize these case classes into bytes, which is doable, or it's supported by default because case classes are serializable.
It is, yes, but you wouldn't get as compact a representation, and if you wanted things like union fields, enums, I don't know if that would, if the serialization machinery extends to that.
Since Cryo does reflection and inspect the fields, as long as you don't have any cyclic or weird objects are not serializable, like as long as everything that you use here, like shapeless or the other fields are serializable, it should be, and it will make things much easier.
I haven't really worked with Cryo before, but I don't know if it's necessarily as compact as something like Avro.
It will not be, but it will be easier, code-wise. Like you don't have to do all the menu.
Well, you don't have to do it with this either. And also, it has reflection. I don't like reflection. It's personal opinion. But I honestly didn't really look into cryo. I hadn't really had an experience with that before. But second question, right? What made us drop Thrift from consideration? So it's more that we chose Avro because it has such a good data support among data science tools. Like our data scientists really just wanted to use that, and it has this great support. There's an existing ecosystem. The folks, there's a lot of existing support from Kafka, from Spark, that you don't really get with Thrift or Protobuf. I don't know. I mean, theoretically or hypothetically, we could have also built out like the same tooling in Thrift or in Protobuf, but it's already there. It's easier just to work with that. Does that answer your question? Sorry.
Hello. Essentially, can we drop off the generator? Because if I'm in Spark and so on, I don't want to serialize all of these classes and jars to the clusters, right? So it's very cool for testing and so on, of course, right? Yeah, I completely agree. But in runtime and production, I want to get rid of that. Is it possible for now?
Oh, totally. Well, all right, to repeat the question first. So one of the things with this is that Scala check becomes a runtime dependency, not just a test dependency, because you have these gen instances on the companion object. That is something like adds a bit of heaviness. You might have to have those jars if you're on Spark. That is something that I've been wanting to take care of, to somehow move that from the companion object to something that would only be required in tests. If anyone has any ideas how to do that, I'd love to speak with you after. Or submit a pull request when you open source it. But yes, that's a very good point. That's something we do want to do before this is open sourced or after. Does anyone else have any questions?
Well.
All right.